Okay, in this video, I'm going to show you a technique of linear interpolation. Okay, let's begin. Okay, you see the problem in question. Okay, seems fairly a typical question where you are given a percent or probability value of 15%, and you're asked to find a specific z value. Okay, let's draw a picture first. Okay, that's normal distribution curve. 0 for z in the middle, and z1 should be somewhere in the positive region. Why? Because z is greater than that z1, so that means going to the right, and it's less than 0.5. Okay, I'm going to exaggerate the picture a little bit. That clearly is not quite 15%, but it's okay. So I'm going to exaggerate. So that little right tail is supposed to represent 15%. Okay, so you have to find what that z1 value is. Right, and the way we normally proceed on with this kind of problem is we know our table gives us this, which I label A of z1, and hope you can see that A of z1 is 50%, 0.5, subtract 0.15, which gives us 0.35. Okay, so you think that, well, that should be pretty easy. Go to our good old z table and look for 0.35. So let's see, where is 0.35? 0.35, 0.35 is not here. We see the two numbers that are closest to it, which are 0.3485 and 0.3508. But there is no 0.35. Okay, so what do we do? Alright, let me just go ahead and summarize what we just saw in the table. In the table, we see that, I'm just going to put this side by side. Okay, right here. We see that when the z is 1.03, our probability is 0.3485. When the z is 1.04, then it exceeds the 35%. Okay, let me just kind of put this in a table format. I'm going to have a two-column table format, z and a of z. When the z is 1.03, our a of z is 0.3485. Okay, I'm going to skip a space here. That's on purpose. And when our z goes to the next value, 1.04, then it gives us 0.3508. Again, that's coming from these two p values. All right. What we really want, we don't need that anymore. What we really want is we want our a to be exactly 0.3500, because that's what we computed here. And the z1 value is somewhere between these two. Okay. Now, if you're lucky, sometimes this number, the middle, is smack in the middle between these two. Then, if that's the case, our z1 should just be the arithmetic average of the two z values. In that case, it would be 1.035. But unfortunately, that is not happening. Okay, so what do we do? Okay, so this is now so-called technique of linear interpolation. And what you're going to see is, basically, it's going to be a ratio proportion problem dealing with a whole bunch of differences. What we're going to do is we're going to find the difference between these two. Okay, I'm going to call that change in p, since a is all supposed to be the probability. I could have used change in a, but I'm going to use a p. And there's also this difference. That's also a difference in p, but I need to distinguish between these two. Okay, I'm going to call this so-called a big P, or big change in p. Okay, and this small change in p. So let me just use a subscript change in P, the big one, change in P, the small one. Okay, and I'm going to do likewise on this side. I also need a change in Z's. So this one I call change in ZS for small, and this difference, change in Z, the big one. Okay, hope you can follow the subscript. S for small, big for B for big. Okay, all right, now with these, what we're going to do is now form a ratio. Okay, the ratio of change in PB over change in PS. Okay, so the big change over the small change, that ratio must equal the change in ZB over change in ZS. Okay, and I hope you can see that among all these changes, this is the one we're after, change in Z small. Why? Because once we know what that value is, all we have to do is add that to 1.03. That should give us our desired Z1. Okay. As a matter of fact, all other changes, we already have our result. For example, change in ZB is automatically 0.01 because the two Z values, 1.03, 1.04, only differ by 0.01. These two changes, well, we do need to do some computation. For example, change in PB, subtract these two. Take your calculator. Let's go. .3508 minus 0.3485 gives us 0.0023. So again, the meaning of that is that two p-values, 0.3485, 0.3508, differ by 0.0023. Okay, and we can do the similar thing for change in PS. Okay, I don't quite have enough space here to write this, but all I'm going to do is subtract 0.35 minus 0.3485. If I do that, 0.35 minus 0.3485 gives me 0.0015. Okay, so hope you can follow where I got these changes. Okay, now we are ready to input these numbers. So what we got is this. Change in PB is 0.0023 over change in PS is 0.0015. That ratio must equal to change in ZB, which is a nice simple 0.01, and the only remaining unknown value is this. Again, that's what we're after. Okay, and hope you remember from your algebra class that you can always solve an equation where each side is a complete fraction. We can solve this simply by doing what we call cross multiplication. So I'm going to multiply this times this. That gives me 0.0023 times this so-called, you can call it unknown variable if you like. That is equal to the product going that diagonal, 0.0015 times 0.01. Okay, simple equation to solve for this one remaining unknown. Divide both sides by 0.0023. Plug these numbers in the calculator, and that should give us our desired change of z, so-called the small z. Okay, let's do that in the calculator. 0.0015 times 0.01 divide 0.0023. Okay, it's giving me the result of 0.00, hope you can see it's a little bit blurry, 0.0065217 and so on. We don't need all that decimal. Okay, let me just write few. I'm going to round that off to 4 decimal places. Okay, 4 decimal places. Okay, that's not our final answer. That's only our so-called change in z, the small change. What we need to do is take that computed value, add that to 1.03. So here's our final answer. Our z1 is 1.03 plus 0.0065. Okay, giving us the final answer 1.0365. That's our final answer. Okay, and we can do a little bit of check. Okay, this one is greater than 1.035. Why 1.035? Because that's so-called the middle value between 1.03 and 1.04. Now, is it reasonable that we got a value that is larger than so-called the middle value? Well, look at this number. If you look at so-called the three p-values, the 0.35 is further away than from 0.3485 than it is to 0.3508. As you can see, so-called the changes here, this we found to be 15 10,000ths. This is only 8 10,000ths. So we do expect our z1 value to be closer to 1.04 than it is to 1.03. That's just a quick checking technique. Okay, but basically this is what we call the linear interpolation technique. All right.